Good day everyone. My name is Jason C. Tubalias, a BPED 1A student.
I am here to tackle about how to find the Fibonacci sequences using the golden ratio.
So what are Fibonacci sequences? A series of numbers in each number is the sum of the two preceding numbers, where by the definition, the first two numbers are 0 and 1. The sequence of Fibonacci numbers is defined by the recurrence relation. F sub n is equals to f sub n minus 1 plus f sub n minus 2. Though found in many cultures, the sequences were named after Leonardo of Pisa, also known Fibonacci, after he published a book, Introduction, The Sequence to Western World. The golden ratio consists of two quantities, A and B, such that A is greater than B and A plus B over A is equals to A over B is equals to the golden ratio, where the constant value for this golden ratio is 1.618,033,988,749,89. This constant is formally represented as the golden ratio is equals to 1 plus the square root of 5 over 2. The golden ratio appears in nature, such as leaf patterns and math, especially geometry and Fibonacci numbers. We have shown the Fibonacci sequence as linear recursion formula, where f sub n is equals to f sub n minus 1 plus f sub n minus 2. The closed form for the nth Fibonacci number is related to the golden ratio as follows. The formula for this is f of sub n is equals to the golden ratio raised to n minus 1 minus the golden ratio raised to n divided by the square root of 5. This closed form expression is known as Binet's formula. Golden ratio and Fibonacci numbers. Proof is by indication given the golden ratio is equals to 1 plus the square root of 5 over 2, where f sub n is equals to f sub n minus 1 plus f sub n minus 2. Want to prove Binet's formula. F sub n is equals to the golden ratio raised to n minus 1 minus the golden ratio raised to n divided by the square root of 5 for all n. Assuming that f sub k is equals to the golden ratio raised to k minus 1 minus the golden ratio raised to k divided by the 5 is true. Show that f sub k plus 1 is equals to f sub k plus f sub k minus 1 is true. So let's move on to our example. Find the 45th term. So the formula for this is the golden ratio. X sub n is equals to the golden ratio raised to n minus 1 minus the golden ratio raised to n divided by the square root of 5. So we are finding for the 45th term. So the constant value for the golden ratio is 1.618034 raised to 45 because we are finding for the 45th term, minus the constant 1 minus 1.618034 raised again to 45, divided by all to the square root of 5. So next, here's the solution. X sub 45, because we're looking for the 45th term, is equals to this 2 billion. We find this through using our calculator. So the value for that is 2,537,721,430.0088315 minus stay 1 minus 1.618034 raised to 45 divided by all to the square root of 5. Next, substitute 2,537,721,430.0088315 remain. So, following the PEMDAS, Let's minus the 1 minus 1.618034, so that will be 0.618034 raised to 45. Then divide the square root of 5. So here, just copy the first number, 2537721,430.0088315. So how did we come up with this 3.940547296? We just raised the 0.618034 to the 45th power. So the answer for that is 3.940547296 divided by the square root of 5. So let's subtract 2537721,430.0088315 to 3.940547296. So the answer for that using your calculator is 2,537,721,426 divide the square root of 5. So here is the final answer. So the 45th term of Fibonacci sequence is 1,134,903,523. So that's how you get for the Fibonacci sequence using the golden ratio. So that's all. Thank you for listening. Again, this is Jason C. Toballas, a BPED 1A student.